So, hello, we are live. We are live here. So I would say to everyone here, a very warm welcome to our meetup today here at IBM Developer Europe channel at Crowdcast. The channel provides you frequently interesting content, as you maybe a lot of you know, all is related to development topics from developers to developers. My name is Thomas Südbrücker and I'm a developer advocate at IBM. And today I'm your host for that session. I kindly want to remind you that session will be recorded and will be available after the end of the meetup at Crowdcast. If you have any concerns or objections about that, feel free to leave the session now. For those who are new to Crowdcast, we recommend that you use the Ask a Question. Yeah, here's the Ask a Question button at the lower end of your screen. So, and enter your questions here. So that's easier for us to manage. And Tobias will answer your question at the end of the session or during the session if the question directly fits to the topic he's currently on. So it's awesome that we have Tobias as our speaker for today. He will share with us his experience related to modern enterprise architectures. Maybe you have questions in mind like, what about monolithic applications or transactions? Should we use microservices to transform our existing application when we're starting to build modern enterprise architectures? So I'm excited about what you are going to show us, Tobias. I would say the stage is yours, and start with your exciting session.
Thank you, Thomas. Then I quickly share my stuff. So again, maybe you've joined last week already. When I don't look in your direction, that's just because I am actually having two screens, and the one that is with you guys and the questions is the one that I'm not directly looking into, so don't be worried. I'm fully with you. And now you should be able to see my screen. And last week we had a discussion, what is a mainframe? And you already saw one of these little nice machines on the left side in that presentation. So today is more the wider scope. So how can we have modern enterprise architectures also with enterprise IT systems, of which mainframe is one? So the question is that I generally ask here, is it a legacy or is it a goldmine, or is it some old stuff that we want to leave behind, or is it maybe something we can actually make use of a lot? So we try to answer that question today. And when we look into the charts, I start with a little bit of trivia. So I find very interesting, being a mainframer myself, that a lot of people in the world today see cloud computing as a great euphemism for centralization of computing services under one server. This one is from Evgeny Morozov. And I find that very funny because mainframes at the time were kind of the centralized systems for the world at that point in time, and could have been seen as the enterprise clouds that were used at that time. And one other very important one of Paul Maritz to me is that cloud computing is about how you do computing, not where is your computer. Because these days we have a lot of discussions that people think cloud computing is just the same as before, just in someone else's data center, and otherwise we will stick to the same. And I think that is a very complicated idea to have. And for those of you who may know me already, they know I love Geek and Poke comics. So to the right, you see one of my at the moment interesting Geek and Poke comics, and the topic there is that the one guy says, when we decided to create a new microservice, we need just 30 seconds to get a blank microservice running in the Kubernetes cluster. And then there is the discussion about the naming, and they say you just need another week for finding a funny name for it. And he says it's 2 weeks. So naming is quite important these days, and good naming conventions is something that I learned on mainframes quite well. People on the x86 world sometimes have a very long name, but not always one that is speaking to the people. So good naming conventions is quite a thing to do. When you talk about cloud computing and modern enterprise architectures, I tend to think of this topic of a cargo cult. So maybe some of you guys know. If we would have been all sitting in one room, I would now pick one of you and ask the questions if you know what it is. As this is a little bit more complicated and we have very limited time, I will quickly explain it to you. So basically, it is let's say a cult that is that was developed by the Western civilization when we in the late 19th, early 20th century, we actually find a lot of uninhabited land or uncivilized land at the time where the Americans built their army bases, and maybe they started with planing a big long lane, and on this lane then they stand and just wave with some flags, and then there's a big silver bird coming from heaven, which is basically the cargo that we speak about. So after the Americans then didn't need that many bases anymore because the airplanes were better, they actually abandoned them. And what happened then was that the people that lived there and that watched all of this, and that they basically saw there are people standing with flags waving, and then there's food coming from heaven. And so they thought, maybe we can do that too, because we got used to it. I mean, the Americans shared their stuff with the indigenous people, so they got used to it, and they wanted to do the same thing. And so after the Americans left, they basically started to recreate what they saw at the time. So they built headphones with coconuts, they built glasses from bamboo, and they have big banana leaf parabol dishes and stuff like that, and they built even old airplanes and stuff. So they basically mimicked what they saw. And of course, we all know that this was not really helpful, because the silver birds from heaven didn't came because the setting that these people saw, and it was also not helping to wave flags. The airplanes just landed because there were a few people a few days before actually giving some notice to the American bases somewhere else and saying we need some food. And that was not transparent to those people. And these days, a lot of technology discussions remind me a lot of this story, because people say today's cargo cult is, for example, the cloud cargo cult. So we all know cloud is the best thing to do. Everyone wants to have cloud. Hybrid cloud is the future. Cloud. And everyone wants to be a bit like Netflix, a bit like Spotify and all of these other vendors. And I think that is a bit misleading, because, of course, we need to understand that there is a total different business model behind a shop like Spotify or like Netflix that allows different ways of interaction with their software. So that is very important to have in mind, that not everything is as easy, especially when it comes to real enterprise-grade software, where transactionality is quite an important thing to do. So when we look at where mainframes are these days, I have a little bit of a dated one. This is a Z14, so not the newest version of it. But we usually see those mainframes and those enterprise systems as systems of record. So mostly when we speak about systems of engagement, today's web apps and stuff like that, these apps are based in cloud native runtimes, sometimes in the public cloud or in cloud native runtimes in their own data center. And they are then somehow integrated with these systems of records that holds the actual customer data. So even here is where actually the music happens. This is where it comes from. So we definitely need to have good accessibility of these data. And these are still important, even if they were seen as kind of the old world. And this is the new world. So this is something I want to hopefully clean up with after this session, and we want to have a short look at what the reality is. So when we look at the most modern mainframe, we already had some of these charts last week. We see that the modern mainframe is still kicking. So IBM Z is still a platform, a technology system. We tend to not call it mainframe anymore. We call it IBM Z. As with the term mainframe, a lot of people associate very old technology. So actually it is a very modern server, and it has a very modern technology piece, as you can watch in the crowdcast I did last week. But this week we want to skip it, and we just look at the features that are important. So one is that we have a very high standard in encryption. So we can basically encrypt a lot of data because we have in-chip encryption. So we don't need to actually use CPU cycles to encrypt something. We have special dedicated pieces in the chips that do that. We of course do some cloud native provisioning. That means we use the same technology blueprints as on other platforms, and we have still a high performance machine. So when you recall the session from last week, especially when you have big monolith, it's very important that you have a high single thread performance. On the more, let's say, soft side of things, we have to streamline processes, because what usually happens with customers that use enterprise systems like IBM Z, they have a very traditional way to manage it. So it is not very agile, not very DevOps-ish. And when you come into the teams, you feel a little bit like an alien, because they have a very, from your point of view, maybe dated way to actually manage that machine. We have sometimes a little skill issue. So when we talk to people that are working with mainframe, with IBM Z computers, they tell us we can't find young people. That is also sometimes a big problem in how they ask. So sometimes they say we need young people that need to be age 20, 2,000 euros a month, 20 years of experience with Z, 20 years of experience with CICS, 20 years of experience with COBOL. And of course, you can imagine that's not the case. Either you get you can either have the last 3 ones, which is 20 years of experience. That will give you like 2,000 euro an hour or a day per person, and 20 years old is not really happening then. It's more like 20 years until retirement, or until the end of service in this case. So if you want to have skills, you of course need to have some investment in actually education. And last but not least, we have plenty of existing applications, and we will look into that a little bit deeper later on. And we, of course, need to integrate those applications with new requirements. So from IBM's perspective, we talk about a hybrid multi-cloud strategy. And of course, we will have public clouds, and no one is actually doubting that this is a very important bit in the future. We all kind of accepted that there is private cloud environments as well. But to make this truly hybrid, it is very important to integrate all your existing IT infrastructures that you already have written in the past 20, 30, 50, whatever years. So when we look at the IBM Z assets, so the applications that run on Z, it is important to actually open up those applications, for example, via APIs. That is a model that we can look up, or even modernize those applications. Some people have the feeling that they want to have a complete cloud-only world in the future, so they have to modernize these applications into this hybrid world, maybe in the public or maybe in the private cloud. When we look at how customer situation is here today, we sometimes have the feeling that the cloud adoption is already fully done. Everyone is talking about cloud as if there's no on-premise anymore. But when we really look into it, we are at the very beginning of it. So we just started with the low-hanging fruits. So the applications that run in public cloud for large-scale enterprises usually are the very easy one, the simple ones, and not really the very complex ones. And sometimes people have the feeling that we move to completely off-prem. So basically all the applications will run in some other data centers at a point in time. But we already see that with the time flying by, we notice that customers understand maybe it will not all be public cloud. Maybe we will have a lot of private cloud in our own data center as well. So there's quite a coexistence, and this coexistence will actually never end. It will just be more complex after time. So we don't assume as IBM that everything will go to public cloud, and we assume, especially with enterprise customers, there's a high demand either from regulatory perspective or from a performance perspective to have your own data center still after adopting public cloud services. So when you look at IBM, for example, you may notice that we are quite an open source company these days. We understand that as a company, we understood that it is not in the interest of customers to have proprietary software, to have proprietary standards. Customers actually want to have the highest security that they can get, but they want also open standards. And that is the main design criteria for IBM Z these days. So we try to make IBM Z a very open standards system and help you guys to transform your applications running on it into that direction as well. When we now look into the big trends in application development, we basically see, and most of you may have experience with it, that we have microservice applications. Sometimes 12-factor applications are mentioned, cloud native applications, and you might say already this is kind of the same the same topic, and that is true. Also, API technology is not something totally new. A very interesting aspect when I talk to application architects at customers is that they prefer a polyglot development system. So basically, everyone is able to use the tool that is best suited for their task. But you find that this is in kind of some problem with the performance task. So if everyone wants to use whatever he wants to use, on the other side, it still needs to perform very well. It is kind of complex to achieve that. But we will come to that in a little bit. We will have just some few introductory slides in this cloud native idea and what it means. So this picture on the right side, I think the origin of this graphic actually might be from Pivotal, shows some very nice graphic on how I view cloud native development. Because cloud native development is not something that came out of the blue. It is something that actually is a result of problems that we have with our approach today. And a lot of companies basically want to do the same thing all over, but they expect different results. And that is that's a quote that people tend to say it is from it is based with Einstein, but actually it isn't. One doesn't really know where it comes from, that insanity is doing the same thing all over, but expecting different results. So of course, things needed to change. Business requirements these days coming much faster into the IT organizations. They need a more holistic approach, and the big division between operating and development doesn't work anymore. So basically, what the term cloud native for me personally phrases is the use of certain technologies when you develop applications, the usage of DevOps and the continuous delivery. So you basically have a different development model where you actually work together with the operations folks at the beginning of your project already, and you bring this service that you start very early on together with everyone, and you bring it into a continuous delivery pipeline where you actually start to deliver very small and then enhance and enhance. And the development architecture for your future application might be microservices, and let's say the development packaging is done in a container fashion. So when we have a look now at the microservices itself, when we look at the graphical representation, it looks quite simple to do. Today's monolithic applications consist out of a lot of different, let's say, modules or applications or programs that make use of a common big database that may host different data components. And at first, there's nothing wrong with it. But of course, it comes with some responsibilities and issues. So with great power comes great responsibility. And when you look into it, you see already if, in this case, the triangle is using some of the circle data, there's a hard affinity that the circle data can't be changed without also changing the triangle. And this is a very annoying thing for application development with customers. So of course, they have to manage these dependencies. And if the circle guys now have a big project to modernize their application and their data, but the triangle people haven't, so the triangle people are actually not willing to change their applications, we run in a very much deadlock. So the idea of microservices basically is a very neat one. We say every service hosts his own data or its own data without actually allowing anyone else access to it, except they use proper APIs. And to do this now on a graphics and visual way, this is very easy to do. But when you want to do this now as a transformation project, it's very hard to do, and we will come to that at the end of the session today. But that was just some introduction. And when we now look into it, there have been several attempts to describe it. I think the most known one and the most famous one is the one that was done by Martin Fowler. Martin has a lot of articles on his website about it, and I think they are actually still one of the best sources to look into it. And what Martin says, it's about componentization, it's about business capabilities, products, not projects. So I myself live in Stuttgart, but actually we just finished a very, very famous project that a lot of people know in the world, the Berlin Airport. This is a project. It's something that started like 10, 15, 20 years ago, and it's just about to finish, and it had lots of problems. This is really much a project. A product is more a thing that you can actually oversee and you understand, like building a chair. So building a chair is something that doesn't take that long. So if you actually build products and not make big projects where you change a lot of things, that is actually a helpful thing. When we remember ourselves back in the times of service-oriented architecture, we had very clever pipes. This is not the case for microservices as well. Actually, we have dumb pipes in microservices, and we have very clever endpoints that actually make use of the data that we get. We have a very decentralized government in this future, because in this future, we will see that every one of these microservices can be governed very differently. We have also a decentralized data management. This is also very much a downside, as we will see later on from a enterprise perspective. And we have to do a lot of automation in our infrastructure to keep all of this work. And generally, a very big design pattern here is to have an evolutionary design and to design each of these applications for a possible failure. 12-factor apps have a different spin on the same topic, but in the end, they end up with a very, very similar way of looking at things. So you have to have a common code base. That is something that most of the enterprise customers don't find too shocking. You have to manage and declare your dependencies very, very explicitly. So not just say, oh yeah, maybe it is depending on something else. You need to actually explicitly declare it. You usually don't store your config in the code. That was a good pattern for quite a long time already, but sometimes people tend to forget that. We use backing services, and that maybe is one of the bigger differences from the definition perspective. When you look at the microservices, you generally have that view from Martin Fowler that the data shouldn't be too much shared and that there shouldn't be too many backing services, but the 12-factor apps explicitly allows that, and allowed to treat backing services basically as attached resources. And that, I think, comes a lot of enterprise designs very neat, because they always rely on some common services. So backing services is quite a thing. Build, release, run, that's a DevOps topic, very fast. I mean, use every app as a different process and use very stateless development methods. That's also something we've heard before. The topic of port binding and concurrency, these are now a little bit more very specific to the topic, and I think all the rest, I mean, like using more logs. When we work with enterprise systems, people tend to use more monitoring for that. But if you work in a very microservice fashion, there's also the idea of pets versus cattle. In the traditional enterprise systems, we use our IT systems more as pets. So we have our database and we like our database. If our database is behaving very badly and maybe it's getting sick, we take it to the doctor, namely the support, and we try to care for it. On the other side, when we look into cloud native architectures, we would treat a lot of the services more as cattle. So just imagine you are in the middle of the wild west somewhere, and you have like 2,000 cows. And if one cow is actually getting really sick, you may not wait for the doctor to check on it. You may just shoot it, and as you know, there is every day a new cow somewhere, as you have so many of them. So you don't care too much. And that is the same topic here. If you actually shoot your services when they behave badly, you have to rely on logs, and this is very important for you. One of the more simpler looks at it is saying the art of is having a look at Abbott and Fisher, who say the art of scalability is at first you have to think cloning, so you can actually clone services systems to make more throughput through it. You have to actually divide every application into different services, and if you need even more performance, then you want to also partitionate your data. And your nirvana basically is the kind of the back right corner. So when you start here, you want to do also the duplication, you want to do the data partitioning, and you want to do the functional decompensation. So it works always if you do all three of the dimensions. You can't just do one of it and make it work. So why do people want to have microservices? Of course, we already noticed they are very agile. It helps to actually faster the iteration cycles in a bounded context. They want to make it more scalable, as you really have good use of microservices, it's much easier to scale them as they are stateless, and you want to have a very resilient system. As you have plenty of them and you kill one, it's fine. So there's some good, and this basically is an explanation of what I just said. But there's also some downsides with microservices, and one very important one is that we have no transactional context over more than one microservice. So when you write microservices, it is very important to understand how you want to cut those microservices out of your existing functionality. Traditionally, this is where lots of the service thinking goes wrong. So people tend to think of everything as a service, and you end up with like thousands of microservices. But you actually need to have a transactional circle around some of those, and this is actually something you don't want to implement. If you have to do a saga or another pattern like compensation, that is harder to do. So you need to understand what consistency means. Consistency is not always given in type of eventual consistent data stores and stuff like that. So you need to be aware of that. This doesn't matter if I talk about Google searches and stuff, or if I talk about Netflix videos, but it might matter a lot when we talk about banking systems. So if I want to get a loan and I don't have enough money in my bank account and I don't have any security deposits, it's maybe important for the bank accountant to know that when he wants to approve the loan or not. So the consistency topic is a very important one when it comes to enterprise applications. Of course, there are reasons why you don't want to be consistent all the time, because this limits yourself as well, but this is an important point. The data denormalization, as we saw before, when we have different services that all host their own data and they are all actually able to live on their own data, it's very important to understand that a certain degree of denormalization maybe happens, and you need to manage that well and wisely. The complexity in the runtime is also the issue with the performance. So if you actually have plenty of services that run at the same time and that are managed maybe in a Kubernetes cluster, it is very hard to actually allow a very good performance if there's a lot of interaction between different services. And to me personally, the idea of polyglot development, everyone can use what he wants or she wants, is not the greatest one, because then you end up with one piece from every basket, and it is quite complex to manage that in long term. So some truth about, or some thoughts about microservices, and I explicitly didn't use any of mine. I used other people's opinions on this, but I completely agree with those guys. So Alvaro Sanchez had this nice little picture that said, basically, if you have a very bad written big application today, it's called a monolith, and you just divide it into smaller bad applications. In the end, you end up with the same amount of bad applications, maybe even more than before, but it is still a bad application. So if you want to really, really, really work good microservices, you need to have some other thinking than you used for the monolith. And same this architect Clippy said, so maybe some of you guys follow it on Twitter. If you have a very poor structured monolith, it's very hard to convert this in a very good structured microservice. Mostly you will have a very poor microservice after this as well. And if people are not able to actually create good monolith, the chance is very high that they will not actually win with microservices. That's a quote of Simon Brown. So I think when you work with microservices, and there are very good reasons for it, you need to have a very good understanding on what you are doing and why you do this. So when we look into enterprise systems, we quickly see that most of these enterprise systems tend to be monolithic. And that is not just by accident. This is actually happening because there is a good reason to actually do so. And if you want to break them down into smaller pieces, or you want to maybe componentize it, it is a very good idea to start the componentization within the monolith. So without breaking everything into different processes, but start to componentize your application, maybe already, if it is a big Java application, componentize it within the JVM. And when you did a very good job with it, and you have a very good understanding of the APIs within your application, then the next step is to actually tear it apart and rip it apart into different processes. But you need to be very careful with that. So when we look now at IBM Z, what can we do to make all of these things a little bit more easy for you. We basically have different points of view to it. So we can actually ask ourselves, how can we transform for cloud native? How can we actually have a cloud native experience on the system? How can we use private clouds on Z that don't look like mainframes and they don't look like 3270 screens? And what about public cloud? That is one of the most classical questions that customers then ask and say, so when IBM says the mainframe is quite a good machine, why don't you use it yourself for the public cloud offerings? And we actually do, as we will see later on. So the first thing I think to do when you really speak about modernizing your system, DevOps is key. Having a modern development cycle, that is the most important thing. Because at the beginning of the crisis, we heard a lot of people moaning about COBOL code and that this old code is still running. And I think I said it last week. It was the governor of New Jersey, I think, that was complaining at the beginning of the crisis and saying, oh yeah, there's this old COBOL application and that's annoying to us because that is holding us back. When we then looked deeper into it in the press, we found out that actually the COBOL applications were running very fine for the last 40 years. But the web servers standing in front of it maybe had some problems. So it is not just the COBOL code, because the COBOL code maybe is very good, but the way you interact with the code tend to be a little bit archaic to a lot of people. So it is very important to develop these days in systems that people know of. If you start development in 30-70 screens, black and green screens, that is very hard for young people to get into. Of course, it's not impossible. It's quite easy to do so. I mean, in the end, of course, everyone can have a terminal and can use VI. If you can use VI, there's no reason why you can't use ISPF, but it feels a little bit different. And so people are very much interested in having the same technology to develop. And then the language of the development is not that much important. But you see in this little picture, the culture is the very central thing. So you can buy a bunch of tools that will not give you DevOps. That is just a warning up front. So when we look into what DevOps means, and there's this so-called infinity loop thing, DevOps basically is a big, always going on circle thing where we start to code, we build it, we provision it, we test it, we release it, we also monitor it, and we plan what to do next and analyze it again. And then we start all of this again and again and again. And we try to minimize the let's say the size of each artifact to a very small portion so that we can actually have a lot of throughput and have incremental benefits every other day or every other week, depending on your the length of your scrums, of your sprints. So when we look at the tooling side, we look at mainframes. We often see that people have their planning system still using Word, Excel, not really stuff like Jira, GitHub to actually capture those. On the development side, people tend to use ISPF. In the distributed world, they use Eclipse, they use Visual Studio Code, maybe they use something else that totally is free up to them. When we look at the source code management systems on mainframes, they are often library managers. So it is not like a modern distributed system that can actually have many people working on it. It is a library system where a single person only works with a single piece of code and not people in parallel can work at it. There's usually nothing like a pipeline coordinator on mainframes. So this is usually done with normal automation tooling, but it's all very manual and very self-written. Quality control is often not implemented with Z. Of course, you can use ZonaCube, as you see here, but traditionally people don't use that. And that goes just on for the rest of the topics here. And when we look at this new hybrid world, there's no reason why you can't use a Jenkins server to actually build COBOL code on Z. Why wouldn't you? I mean, in the end, you just call in Jenkins a compiler, and this compiler can be a COBOL compiler. Why wouldn't it? So that works well. COBOL code is just some text files. So there's no reason why you can't place this in Git. So that would work as well. Same is true for ZonaCube for testing. I mean, you can in ZonaCube test if there is a dot or not a dot in COBOL. For those of you who know COBOL, there's a lot of dots involved in COBOL. And DBB as a helper for the pipeline to actually execute mainframe compiler systems using unit tests, and so on and so forth. So there's basically technology for all of these topics that we can use on Z that feels like developing Java code on a distributed system or feels like developing Go code on a distributed system. So all of this is working. Of course, this is a project. This will take time that you actually need to invest as a customer. And we see some customers doing really great investments. We have customers that can do most of this stuff now they can actually develop Visual Studio Code. They can develop in Visual Studio Code some COBOL code. They check it into Git. They have a Jenkins build pipeline running over it. They get some quality control via SonarQube. And in the end, it is deployed on IBM Z. So all of this is possible, but it takes some time to actually implement that. When we now look at the runtimes, basically these days, it feels a little bit like a lot of people are thinking, oh, cloud, that is something that is open source, we can build it ourselves. So basically they try to build stuff like Kubernetes, and they use their own Kubernetes implementation. They take all the fancy bits out of the open source world and build it themselves. No one would do that with a car. I mean, everyone would basically accept the car as fully manufactured, and we have the same feeling when it comes to actually the proper use of private cloud environments. So people tend to use stuff like OpenShift. You may have different opinions on that. I just focus myself on OpenShift, as OpenShift from Red Hat is quite a good standard for a lot of companies these days already. Of course, there are alternatives, but to my point of view, OpenShift is quite a good technology and quite a good bunch of packages that have been actually combined and actually work quite well. And so these days I work with some customers installing OCP on Z. So it is not running on a x86 platform, but it is running on a mainframe computer, and it works perfectly fine. So the thing is now with using OpenShift on Z, it uses all the features of a mainframe transparently. So if I have, for example, the very high single thread performance, I can make use of it in OpenShift without even noticing. I can use the security features of the IBM Z platform without noticing. I can use the encryption functionality without noticing. And so basically our idea with putting OpenShift on Z and using also the cloud packs, I mean, that's the IBM flavor of OpenShift combined with some other technology. These things used on IBM Z with OpenShift, they are just running the same as anywhere else. So it is the same OpenShift code, it is the same technology, it is just adopted to the platform. And if you are a user, you wouldn't even notice that you run on an IBM Z machine. Of course, that means that your code needs to be able to run on Z. So we don't have x86 Docker images here. We have containers that run on the S390 architecture, but generally it's the same thing. And with the customer I work with, they use the same technology they used before in Azure to build OpenShift cloud images. They now use on their IBM Z platform, and the developer didn't even notice that there's a difference. So when we look at the cloud packs, they just come with they just bring OpenShift with some additional services, and you see there are different cloud packs for different types of purposes. So you have cloud pack for application, cloud pack for data, and most of them are already on IBM Z. Some still in the pipeline, but we actually will have the same technology on all the platforms available, which is quite a cool thing. So it's not mainframe is something else. It's actually mainframe being the same platform as anything else, just better. So what we see people tend to argue with or have an opinion on is that they don't really like the ways we manage enterprise systems so far. So what they tend to wish for is to have a common operational model for all the platforms. And it seems that OpenShift offers quite a good technology stack for it. So we have quite a good automation with Ansible. We have a full stack CI/CD pipeline. We use some storage, and then we use the OpenShift layer basically to hide away some of the complexity of some other systems. That will not take away all the ZOS systems that we have today, but it will actually limit some of the complexity and make it easier to work with. And we will come to that just in a little bit. So if you have questions in between, as Thomas said, feel free to ask them all the time. I come to that when you have questions. So Ansible, for example, for those of you who know it, is a very good automation framework that the Red Hat guys invented. And there's no reason why you wouldn't use Ansible in the same way also for IBM Z platform. So Red Hat automation is something that we brought to the IBM Z machine. So you can these days use it to manage ZOS systems as well as you would use any Linux, Unix, Windows, whatever machine to actually automate your stuff. This is quite a cool thing because if you are now a person coming from the distributed side, oh, there's a question. Oh, that's a longer one. I've quickly finished that chart and then I I come to that one. That if you have this automation done with Ansible, you can actually make your skill a little bit transparent. So you don't need to understand that much of a mainframe computer. You just need to understand how Ansible is working, and you can integrate ZOS machines within a larger scope of automation. So now we come to the question. In the example for the monolith, you said something like the triangle accesses the data from the square directly. The square is stuck with the data structure and the triangle does not want to update. Don't you have the same problem with microservices when changes of data structures can only be used with changed APIs? Totally right. So Gregor, I think you hit the nail on the head. Of course, it's the same issue, just on a different level. Even though I would say that APIs are a little bit more easy to manage, as they are not that explicit sometimes on how the data is physically stored. So a physical, let's say, dependency on a database is always much harder to manage as an API, because an API maybe hides away a lot of the complexity of the data storage, and it's much easier to change the database underneath and maybe even have the API being around for quite a longer time in the old version, but have a new version that already offers a lot more functionality. That is maybe not be that easy when you actually have to use the same database, because if you want to, for example, use a Unicode column in a database, and before it was done in a let's say in a more traditional character set like ASCII or EBCDIC, then it is much harder to actually change that, because you need to change all the programs. If that would have been an API, we can of course understand that there is maybe a more traditional system asking for it that has no understanding of Unicode, and we can actually answer that system with an ASCII or with an EBCDIC, even though the actual physical data is in Unicode, and we can have other systems asking for the Unicode version of the data. So it is kind of the same dependency. So if we have dependencies, we will not get rid of it, but we will abstract it a little more and can make it much easier to actually manage those. I hope that helped you. I hope I gave an answer to that question. If not, feel free to add some stuff to it, and I will look to it a little bit later. Good. So that was the automation bit. When we now look into the public cloud bits, we see that in public cloud, IBM is using actually IBM Z to make services or to build services in the public cloud that have a very that have a very high requirement on security technologies. So the little sample I brought you is how we actually make databases in public clouds. In public clouds, most of the databases come with an operational assurance. So basically, the cloud provider, like IBM, tells you, you can ask for a Postgres database, and we have, of course, operations folks that have access to it, that are the administrators of our cloud data centers, but we will actually promise you that we will not access your data. And of course, all the cloud providers do mean that by heart, so they don't really want to look into the data, but you can of course never prevent for human failure. And if this is very sensitive data, you may want to have a technical assurance, and that's a cool thing with databases in the HyperProtect portfolio. What they actually did is they used the IBM Z technology of completely encrypting the data stream and the service and the pod itself, or the container, to actually allow the IBM operations person not to access any of the data within the data service. So only the customer can actually access, because the customer is the only one that has the key to the data, can actually access the objects within the database. The operations guy from IBM or from other cloud vendors can't. So this is quite a cool usage of the technology that IBM Z provides with the cryptographic features of the hardware, to actually build something that is not that easy possible in x86. Of course, you can do this in software, but this will give you some performance performance issues. And on IBM Z, we can actually build a service that provides this level of technical assurance of your data that is not possible in x86. So we have some services running in the cloud already. This is the crypto services. So we actually provide crypto hardware features to open source systems via some cloud services. We use the database as a service, as you just saw. You can actually make use of a virtual server, so you get a completely virtual server that is secured with cryptographic algorithms. And in future, you may even have protected containers that IBM can't actually have a look into it, versus having a Kubernetes cluster that an IBM administrator can have a look into. So coming now to the question that we had at the beginning, why is it so hard, or is it a problem? Do we need to modernize our existing applications and technologies? So a lot of customers have the feeling that they need to modernize their systems. They have to modernize because of competing goals. Other people are able an insurance quicker than others, or they have a modern banking feature. So these people have the feeling that they have to modernize, modernize things. But when you ask yourself if you want to modernize, it's very important to get some clarity on why you want to do that, and who is actually the one that pays for it, and how is that done for this very long project time. So a lot of the issues are actually already upfront. When you then decided that you want to modernize things, you may ask yourself, why would I modernize at all? And you look into it and you find that the developed features that you have are not really fast enough regarding to your business business requirements that you see. The architecture of your application is maybe, because it's very monolithic, because of the question that we just answered when it comes to the dependencies, because of this technical depth basically that you acquired, because in the beginning every application was designed brilliantly. I just assume that no one starts with a very shitty application. So we always start with a very good idea and with a very good structure, a very good architecture. But then after years, you actually get some more technical depth into the system. Someone says, oh, we quickly need this and that feature. So we quickly hacked it into it. And we said, oh, we should actually figure out how to do that better later on. And maybe also your application is very hard to maintain because you miss off skills. You're running on a very old version of the software stack that is supporting it. So there are a lot of questions to be answered. So some good things that we saw in modernization project to have is to have a very good investment and a very clear understanding of it will not be that easy. So usually a modernization will take years. It's not quickly take it and put it somewhere else. So this lift and shift thing usually is not working when you really want to modernize something. Another key aspect is that the modernization is not just a technical feature, but maybe also one that comes with organizational changes. And last but not least, to change the architecture, development, and the operational process also have to be understood in where we want to go. So it's not always just that easy to do that stuff. Basically, when people want to move to a more modern system, the first thing that I tell those guys is you need to start with a development system, because you need to have a development system that actually allows you to have the same pipeline for your existing code. So maybe with COBOL or PL1 or assembler even, as you want to have with future code, maybe Java or whatever you fancy. Then the next important thing is to understand your application. And this is already a very complex thing to do. It's not that you can just have a tool for it and say, okay, please analyze my core banking system, and then you're happy. And it is really complex, because that is the big issue with these traditional applications that have been around for quite some time. They were very complex. They gained so much functionality that it's very hard to understand. And then the next thing is that I usually advise all my customers not to make big bang migrations, so not to completely rewrite certain pieces, but to actually have a stepwise approach and quickly start with a very small chunk of your code and run this new chunk of code alongside with the traditional COBOL code, for example, or whatever you have, to actually allow yourself to make this new world bigger and bigger and bigger without actually impacting your existing runtimes. And once you've done that, once you reached a modern monolith in Java, for example, then you can also start to refactor the application. Because if you do too many things at one point in time, it is very hard to actually find why some things are not working. I worked, for example, for a customer that a few years back started a modernization project, and they actually did a code modernization. They changed the database in the middle of the project, and they actually changed half the team. So basically, in the end, no one knew what the problem actually was in the end, why this modernization failed, because there were so many moving parts that no one could actually say, was the problem with the database, was the problem with the code, was the problem with the development environment? No one knew. And in the end, then you can ask yourself, if you have this application then refactored in, for example, microservices, you can run that application on x86 and look if it performs better there, or if it performs better in the cloud, or wherever you want to put it. But we are very sure that IBM Z is still a very good and viable platform for your applications. So, but we want to help you to go there. Do I need to, there's a question again. I need to tell that, because then the people, like Thomas, can actually record my answer to the question. So the question was, do I need a mainframe architecture to build container images for, or could I build them on an x86 architecture? So generally, it is very easy to emulate things, because QEMU basically is able to emulate the S390 architecture. So you can actually do that on your x86 machine. Of course, this will cost some performance, and it's not, let's say, a recommended way to really do productive workload on it. But of course, you can do that, and you can emulate the S390X architecture within your Linux system that you have on x86 to build stuff. As said, when you really go into more deep dive technical testing, I would recommend to use a proper mainframe, as it will perform a lot better, but it is possible. Cool. Then I quickly, at the end of my presentation, will take you to a journey on how to actually modernize a system if necessary. As said, it is not always necessary. Sometimes it's just enough to modernize your development pipeline, to modernize some bits of the COBOL application, and maybe there's not even a need to change the programming language. Maybe you are best off if you just add some functionality within COBOL, within PL1, or whatever functionality, or whatever programming language you use. But if you decide you actually must modernize, I quickly have this picture of a technology stack that most customers are using. They use DB2 as a database. They use CICS or IMS as a transaction monitor, an app server. They use some MQ stuff. They use TCP/IP, of course, to connect to other systems. And in the end, all of this is based on ZOS. When we look at the operations folks, they work natively with ZOS. The end users somehow access these applications, maybe as 30 to 70 applications, or even as web service, or maybe even as APIs. And the developers, they use stuff like SCLM, so very traditional library managers, and some build jobs that they have at hand. So first thing we do is we actually want to understand that some of these applications, and they look like different applications here, the app 1, 2, 3, 4, 5, 6, but in reality, they are all very much depending on each other. So if you have, for example, like a partner or a core data application, all of these applications usually have high dependencies on other ones. So for example, if you have a partner application that holds all the customer data, most of the other applications will actually have to call this application, for example, at the beginning of a change in a contract. The first thing you want to do is you ask the partner application, please give me the customer for this or that, this or this customer number. So there are some dependencies. That's the first thing we need to understand. We can use tools for that. We can maybe ask people that understand it. So we understand in our little example here that application 4 and 5 have some kind of dependency. So next thing we want to do is we want to have a modern development process, and of course we can do that in exchangeable. I don't mind too much. I see that we are close to the end of the time, Thomas. Thank you for letting me know. And we can of course do that. And after we actually modernize these system and this development system, and we understand the dependencies, we can start to modernize one application after each other. So for example, we start to modernize this little application 4 and rewrite it in Java, or slowly transform it into Java. we might have in the next step the question, do we really want to containerize it? And I think it's hard to see here, but there's a little container here. So even on ZOS, so on the mainframe, you have the chance to run a Linux container image. So this is then containerized, and you wonder, why wouldn't I put it directly in the public cloud? And that is just because the latency that might kill you, because this app 4 might call app 5 quite a lot, and if it does for a trillion times, it's very hard to place that actually even maybe in another data center. So you want to modernize the application 5 as well, and then you can actually put it on a different stack. And I now use again the IBM Z platform with the OpenShift stack. And why did I do that? Why did I pull it completely in the public cloud? The question or the answer is quite the same as before. If we would do that, maybe application 1, 2, 3, and 6 would have problems. And to be a little bit more honest with you, we will very surely need a coexistence layer in between, because when we modernized app 1, 4, and 5, and in this case, the DB is not the German railway system, it's more a database application. And these database applications will actually store data that might be also used from app 2, 3, and 6. We will have the issue that the latency between the systems needs to be near zero in perfect times, because it will actually break your neck if it doesn't. So this is another very helpful thing. If you modernize, you will have this coexistence in between the old and the new systems. And just after a while, this coexistence layer, in the beginning, the coexistence layer becomes much bigger and bigger and bigger. And after a while, when you modernize more and more application to the right sides, then this application, this coexistence layer becomes smaller again. So this is something that sits in between, and that's just an idea of how you can actually do the modernization. So basically, you have some options that you can use. You can say, I'm doing nothing with my IBM Z systems, and I will actually do nothing to my core systems. That's a very sad story, because then you will fall behind, and most of the times, core systems are important to your business. You can try to re-architecture all of it, do lift and shift. It's quite a risky one, because if you have your core banking application and put it in the public cloud and it's not working there well, you have an issue. Or you can try to use the IBM Z platform as a transformation platform and end up in a maybe better future, and maybe also eliminate the IBM Z platform if you don't find any usage of it in the future. So there's a lot of places where you can make use of the IBM Z platform, and that's the thought I will actually leave you with, and go into the questions phase. And I enable my videos. Somehow it got lost, I think. How can I do that? Whoop, there we go. Are there more questions?
Yeah, it's time for questions. Yeah, you already answered 2 questions. Yeah. Thanks.
I see.
It was awesome. A lot of different perspectives. That's great. So Tobias, with your experience.
There's another question.
Very close.
Coming.
So
there's another question. I quickly answer that because it's a very interesting one. And the question is, why should I buy, as customer or whatever, buy a Z system with a limited number of IFLs that is very expensive to do? And when I can have at the same time a very cheap x86 system, or I mean, if it is cheap or not is another question, but I can have with less money more performance. And the answer to me is quite easy, because in the end it comes if it is possible to do so. To me, most of the modernization projects struggle when they actually try to divide the new and the old stuff with a very long latency, and not just the latency, but also the transactional integration. So when I try to modernize bit by bit a core banking system, I need to maintain a transactional context maybe for a certain amount of time between COBOL and Java. And this is very hard to do if you actually work with a remote system. So maybe, of course, you have a valid point. You choose a very expensive or a more expensive technology basis, but it allows you to actually have a transactional integration between 2 sides. So that is the answer to the first questions. And beyond, all the cool new stuff does not need a Z system. Of course, it's a Me Too system. That's correct of course, you can do that on every other platform. So to me, the point is just, if I have if I don't have the possibility to have a direct jump to the new system, it's very hard to basically do that. So as you said rightly, there's no reason why an x86 system on its own would perform less performant. So the only risk that I see is when we integrate the existing Z system with an x86 system, that loses sometimes the performance benefits, because you need to have a transactional integration. If you do that with Java, I mean, we have the topic of what protocol will we use? Do we use IIOP or stuff like that? I mean, it's quite complex to do so. So that is my only point here, and I didn't want to have the opinion that x86 is not as powerful as a Z person when it comes as a Z machine when it comes to performance. But in the combination and the modernization bit, it is sometimes harder to do so. I hope that helped, Norbert, with the question. And now I ran already over.
Okay.
Sorry.
Oh, no, we directly now here at the end. And so once again, it was very interesting, Tobias, and we already got a good feedback. And I only want now say, hey, here, just take a look. You also welcome to our next session on 5th of November, 12 o'clock. It's tomorrow. Yeah, it's about Cloud Code Engine. Run your source code, container, and batch jobs serverless. And if you're interested, just visit our meetup group here. And with that, I say once again, many thanks to all. Yeah, maybe we will see us in one of the next meetups. And I will end the broadcast. And if you like to, just look it again and again and again. Okay, bye.
Yeah, feedback highly welcome. Cheers.
Cheers.